Greetings of the day, dear students. Under the Department of Collegiate and Technical Education, we are here to discuss about experiment number 1, name is 7805 voltage regulator in the course PCB Design and Fabrication Lab for semester 5 diploma students under the program Electronics and Communication Engineering. A warm welcome to all of you to the session. Let us see first the circuit diagram. Okay, so this circuit diagram you should have with you in your notebook or on a page. Okay, so if you see this circuit diagram, I require the components as number 1 7805 voltage regulator IC and two capacitors C1 and C2 1000 microfarad and 500 microfarad values, and I require 2-pin connector here for giving the input and 2-pin connector here for taking the output. And in PCB lab using KiCad software, I also required another component, power component. It is called ground component, and for each power component I require a power flag. Okay, so these are the components I require. Right, now I will show you how to begin the experiment. Okay, so on your desktop you should open first KiCad icon. On the KiCad icon, you double click it, you will get a screen like this. Then go to file and you just click on a new blank. I want to create a project now, that is 7805 IC regulator. You create a blank project and give the name, any name you want. For example, I will give you give the name regulator REG, for example 7805. Any name you can give. I have given REG 7805. Then click on save, then click on yes. Okay, then here 7805.pro, your project is saved. .pro automatically will come. Now I require an editor for designing the circuit diagram. Okay, so click on this icon. This is called eSchema or schematic editor. Okay, a editor will come here. Okay, just you can enlarge it using mouse, rotating upwards. Okay, then take the components. As we have seen earlier, the components are available here. Place a component library, it is called. Okay, so place a component, click on that, then click anywhere here in the center, then list all you click. Then first I will take regulator IC. Okay, it is there in RE regulator, name is regulator, you can search it, REGUL. Okay, on this you click, all regulator ICs will come here. Pick on 7805 and place it here. Okay, you can zoom it using mouse by rotating upwards. Okay, so I will place the component here. Then I require two capacitors. Okay, capacitors are also available here. You just see here, place a component on this, you click it and click here, and now again list all. Okay, so then capacitor is available in devices. Just search the devices. Okay, it is here, devices. Then okay, in this you take polarizer capacitor CP. Okay, polarizer capacitor, a capacitor will come. Okay, place somewhere here. Okay, I will place it here so that it will be in straight line in this input pin. Then I want another capacitor. You can repeat the same thing, or else same capacitor I want. Then click on C, place this cursor on this, and C means copy. You type a using your keyboard, type C, another capacitor will come. Okay, then zoom it and place in this line. I have placed here, for example. Then what I require is, I require two connectors I require. Okay, so you take connectors here, for example on this, click it here. Okay, then list all, CONN connector, it is there here. In this connector I require 2-pin connector, it will be there here, CONN_2, that is 2-pin connector. Its name is like this in the library. Okay, you can see here. You can rotate it so that it will come. I will press the key R, it will be rotated. And generally it is always better if pin number 1 is above and pin number 2 is below, then right click on this, then edit component, then edit. Okay, so or else even you can take the mirror image also. Okay, on this, okay, right click, orient component you go, and mirror. If you go it, then pin number 1 will be above. It is better to take like this. Pin number 1 is above, pin number 2 is below. Then place it here. Okay. Then again I require another component this side. Okay. Another 2 pin connector I require. So place on this and say C copy. So it will come. I want this side. Again you make rotate. Okay. Again if you see here, pin number 2 has come above. Okay, so just place it first, then on this you right click. Okay, orient component, in this you take mirror image. Okay, orient, then I will take mirror, so that pin number 1 is above and pin number 2 is below. So then 2 more components I have to collect, ground and power flag. Okay, it is there here, you can see, observe it, place a power port. Okay, in this ground is there. So click here, then say you can type it here or list all. If I type G and D for example, G and D, or else it will come, or else list all. Then here you can type G and D. Okay, so here it is there. Please take this G and D, then say OK. Okay, ground you can place anywhere. For example, I will place it here near. Along this line, so that it will be looking, circuit will be looking better. Okay, then I require another thing, that is power flag. Again here instead of ground you type the name PWR, power flag, PWR, its name is there. Okay, or else again list all, better you take list all, and then here you type PWR. See here power flag has come. You take this power flag and rotate it. Okay, and keep anywhere near the ground. Okay, so now I have taken all the components. Now only thing is you connect the wires. For connecting the wires, you see here there is a green symbol, place a wire it is. You click on this, then just zoom it so that you can place wire. Once you click it, then drag it until this capacitor component will come. Okay, then once click it again, once again you click it, drag it here, I require here, then zoom it here like this. Okay, then I will connect here, double click, then again click once here, double click. Okay, then below side you connect. You just see here I am taking from this, double click, then place like this, double click, then place like this, turn it, double click, and place like this, double click. Okay, then from here connect it to ground. Okay, this is, and power flag always connected to ground, anywhere you can connect. Okay, this complete line is ground line. Okay, you can connect anywhere you want. Suppose I will connect it here. Okay. This completes the circuit diagram connection. Okay, when you take the components, you can select the value then only, or else now you can give the value. This is 1000 microfarad as I have shown you earlier. Take this, then right click on it, edit component, then say value. You type 1000 UF, means microfarad. Okay, now you see here 1000 microfarad has come, and this is 500 microfarad. Right click on this, edit component, then you click on value, then type 500 UF, 500 microfarad. I have given the two values, and for this connector also you can give the name. For example, field value, right click, field value, then edit value. I will give input. So you can give any name. I will give, for example, name has input, INPUT, input. Okay, so it will come here as input, and on this side I will give it as name as output. Okay, so again right click on this field value, then the edit value, then give the name as output, OUT. Okay, so output. Now the name has come as output. This completes your circuit diagram. That is, this is called a schematic, drawing schematic. So after completion of this, next step is save this. Okay, here it is save schematic project. You save it, it has been saved. Next step is, okay, go for annotation. Annotate. Second step is annotation. Annotation ಒಳಗಡೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ these question marks are there, no? P question mark, C question mark, okay, U question mark. All for that it will be giving a suffix 1, 2, 3 like this. You can see here everywhere it is question mark. Now I will do the step annotation. It is there here. Annotate the component in the schematic. You click it, okay, and say annotation. Then you say okay. Then you say close. Now you see here earlier question marks were there. Now it has come as P1, P2, and this is named as C1, C2, and this is named as CU1. Earlier U question mark, C question mark, like that it was there. Annotation means giving suffixes to each component. This is the annotation. After annotate, you go for electrical rule check. Okay, if any errors are there, you click on this electric rule check, then test ERC. You click, so test ERC. If any errors are there, this error will come here. So now there are no errors in my experiment. Okay, then you close it. It is correctly connected. Then go for the, after this go for the net generation net list. Okay, in this you click it net list. Okay, then already REG 7805 default it will come because you have given the name as 7805. Then say save. Okay, so after this next step is this one, run PCB to associate components and footprints. Okay, so you just click on this. You have to associate footprints for each one. Okay, for C1 you take it, here click on this, double click on this, then take, for example I will take CP4. Okay, double click on CP4. It is a standard size. Okay, CP4, CP5, which anything you can select. So I have taken CP4, and for C2 also you select CP4, and for port 1, that is for this you select SIL2, serial inline, its full form. Okay, you just drag it, you will get SIL2 here. I am seeing SIL, here it is there, SIL2. Double click on this, serial inline 2-pin connector. Output is also serial inline 2-pin connector you take. And for 7805 IC, you just drag it here. Okay, you can select, I will show you, regulator, .78XX regulator you search, or else it is LM78XX. You go in the L, you just see here, it is there, LM78XX, LM78XX, it is there here. You just associate this with this, because all 78 ICs are with same number of pins, LM78XX. Okay, then you have associated all these things, you just see. Then again you say file, save this. Okay, and file, quit from this. Okay, you have associated footprints. Now next step is, okay, last step, this is run CVPCB. That is, now I want to draw PCB layout. Okay, on this you click it, then say okay, then maximize this. Okay, So on this I want to take that PCB layout. So mode footprint you go, then on this right click, globe move and place, move all modules. Okay, then you say okay. Sorry, in this first you do this net, read current netlist, then close it. Okay, so now your circuit has come here, right? Now right click here, globe move and place. Okay, move all modules, globe move and place, move all modules. Okay, then you say yes. Okay, your PCB layout has come here. Now these white wires were there, you just, they are called as here wires. Now arrange these, okay, properly. First you, let us, I will begin with 7805 IC. You rotate it, okay, and place anywhere you want. For placing you first move, place it like this. Then I know P1 is on the left side, so take this P1, you say M means move. Okay, then I will be placing like this. Okay, see here I have placed it like this. This is input port. Then this port 2 you can take, move. Okay. This is at the output side, I have connected here. Then C1 and C2 you should connect. C1 is at the input side, so therefore I will first I will C2 I will move on this side. Okay, then I will take C1, move it. Okay, let us take, I will keep like this, so that there will be a straight line, and then C2 I will move. So if it is like this, you just rotate it so that it will be in same line. Okay, I will just take little bit near. And this also I will take move. Okay, I think this is better. Okay, this will be the better thing. Okay, so this I think I have kept because I have kept P1 in vertical direction, I will keep P2 also in vertical direction. Then C2 you just see here, I will be keeping C2 like this. Then I will be keeping the IC like this. While keeping C1 capacitor also very near to this, like this. Okay, so after placing all these components, just try it so that this will be better for me. And this will be better thing. Okay. Right. So now put the copper clad put the copper wires on this. Okay, that is add tracks, it is called. On this you add tracks. So already you go here, design rules, dimensions 0.254, it is by default. You select this and take little bit higher. Okay, for example I will take 0.8 thickness. You take it, then go on connecting on this white wire, this tracks. Okay, you just see here I have connected wherever white wires are saying, you connect it. Then I am connecting this white wire, I am connecting this white wire on this. Then you see here where it is connected, it is ground point. Okay, so I should connect on the ground point here. This is connected, then this should be connected here, connected. Then two more white wires are there. Okay, you connect this white wire here, this is your, and last one more ground wire is there here. You can connect anywhere you want. Okay, for example I will connect it. Okay, so this will be your PCB layout. Now PCB layout is ready, right? So you can put the boundary on this. Okay, so for putting the boundary, already if you see here on the right hand side, back side copper is there. You select any front side. For example I will select F mask. Then for putting the boundary I will select this add graphics. Then on this I will be selecting the boundary. For example click it, it will be coming like this. Then click it, turn it, click it, turn it, click it, turn it, click it, turn it. So this will be the boundary I have marked. Okay, then name this circuit as 7805. Again go to back side copper. Earlier I went to front mask, now you go to again back side copper, and then T. Okay, add text on this and type the name, that is 787805 regulator, regulator. I have typed it. Okay, then say OK. Then it will be coming as mirror image. Okay, place by zooming it, you place anywhere you want. Okay, for example I have placed here. So this is the diagram. PCB layout is now ready. Okay, so this is the end of experiment number 1. Okay, so you try it yourself. I hope I am clear to everybody. Okay, try it yourself. Right, thank you.